So these are our syllabus. We discussed about our syllabus, and then we just started with our first module. And in the first module, we just described about the basic things regarding civil engineering, what all the things a civil engineer should do, and what all contributions from the computer science department, like computer science graduates, and also ADS graduates can do in the field of civil engineering. So all these things we have discussed in the last class, and you need to understand this that this course basically the name of the course, as it suggests, is basic civil engineering. So you will learn only the basic things in civil engineering, other all those terminologies that may be useful for you in your future. In detail, we are not doing any complex structural analysis or any other analysis. We are not doing all those things in our course. We are just dealing with the basic things in our as per our syllabus. So we have discussed about the impacts of infrastructure development and about the various disciplines of civil engineering. In this, we've told about first discipline was surveying and remote sensing, where the basic objective is to survey a land. It might be a small piece of land, it might be a large piece of land. So if you are surveying a small piece of land, the basic things what we use is like a chain or a compass, and there are new technologies which have come to use like total station, where it is digitally electronic distance measurement. It's an electronic distance measurement device where we can electronically uh, measure the distance between 2 points without moving around a lot. So this is the latest technology that we are being used, not latest in the sense like for the past 15 or 20 years we have been using this total station in civil engineering survey works. These are all these things which we use for small survey works. If I'm not audible at any point, please do message so that I can do the necessary things. I hope I'm audible now, right? Can anyone respond?
Yes, sir.
Okay.
Yes, sir.
So in the screen you are seeing all those equipments by which a surveyor will do will survey a small piece of land. But as our name suggests, surveying and remote sensing. Remote sensing means that we can get the data about anything without having an actual contact with that particular thing. Let it be a piece of land or anything. So in remote sensing is a wider topic. In civil engineering, remote sensing basically means using satellites, drones, or other things where we don't have actual contact with that object or material which we are surveying. Let it be a building or a piece of land. And see, if we are talking about a large piece of land, what happens is like we can't use this chain survey or compass survey for a large piece of land, maybe like 1,000 acres of land or 10,000 acres of land. So in order to measure that, basically we will have to uh, use technologies like remote sensing, where we don't actually have to be in contact with all those surfaces. And nowadays, this surveying has been improved. Surveying technologies has been improved, that we are using satellite to survey. And you need to understand that all these chain survey, compass survey will work only within a small distance. Next, after that, the shape of the earth will come into play. So what happens if you are surveying a small piece of land? It will be a plain land. We need not consider what the round shape of the earth. Basically, the distance might be around 50 kilometers or 80 kilometers. The shape of the earth, what is the shape of the earth? Spherical shape. So that shape won't come into picture, won't come into matter when we are when we are surveying a small piece of land. But when we go for large surveys, like we are preparing a map of a country or something like that, it will be a very large survey. So at that time, we can't rely on these small equipments, since the shape of the earth will also come into play, and you won't get the exact measurement. For that, we will use some other survey techniques, and we'll hope you will study in detail all those things. In civil engineering, there is a separate branch named surveying and remote sensing, and in that branch, graduates will be learning regarding all those techniques which are being used to survey any area of land. So this is all thing regarding to surveying and remote sensing we have discussed. Then next is the geotechnical engineering. Basically, it deals with the stability of soil, in which we will take a soil and we will study the stability. What is the type of soil there? What are the gradations? What means how graded it is? It might be you will note that clay is very soft and smooth, while sand is thick and coarse. So the properties will also be different in different type of soil. So this is the subject dealing with the strength of soil, maybe the stability of soil. This branch particularly applies in foundation works, tunnel works, all these retaining wall works, and even in offshore works also. This branch applies the techniques. And next is like structural engineering. This is a very important field in civil engineering, where basically deals with the designing of a building or an infrastructure, or a structure basically. So we'll design a structure such that it can sustain the loads which are expected to act on that particular structure. For example, if you are designing a bridge, what happens is like we will design a bridge so that we will calculate the load, the maximum load that might uh, be on that particular bridge, and then we will uh, decide how thick the slab of the bridge should be, how big the pillars would be. That means the columns or pies, what we call in technically. How what would be the size of the size of the beams? What reinforcement? What steel bars should be used in that? What is the grade of concrete to be used? What technique it should be applied? And you might have heard about the bridge named Palarivottam Bridge. So that was basically the failure was due to the technical issue. The first and foremost, the technical issue, in which the proper load distribution didn't happen in that bridge. So that what happened was like nearly 40 or 50 crores of money was wasted in that bridge, since the design was not proper. That was the first issue. Then there were a lot of other issues basically after that. So you need to understand that a structural engineer is a person who designs a structure. Similarly, it also applies for other structures like buildings, uh, or dams, or any other things, where we will decide the size of that particular members of the structure so that the load will be safely transported to the ground. And once it reaches the ground, it's the geotechnical engineer's responsibility to ensure that the ground has the sufficient strength to carry that load. So these are the branches. The next is construction engineering. It deals with the management. It's basically a management field where we will manage a site or a construction activity. We'll schedule the activities. We will uh, ensure the proper supply of materials, labor. We will use a lot of techniques to ensure a proper distribution of labor, materials, etc. And we will try to keep on with the schedule. All those activities will be carried out by a construction engineer. Next is a transportation engineer. Basically, a transportation engineer designs uh, our transportation facilities like roads, bridges. Bridges mean in the sense, uh, and then in traffic junctions. We will also design the traffic movement in a city. All those things will be carried out by a transportation engineer. You can see all those examples. Next is an environmental engineer. Environmental engineer basically uh, assures that our living environment is safe and sustainable. Uh, Environmental engineer's responsibility is to ensure proper water supply, and also to dispose the wastewater, solid waste, ensure that the air pollution is under control, water pollution is under control, So all those responsibilities come under an environment engineer. Next is water source engineer, basically deals with irrigation, water supply, all those things. So water source engineer, basically he it's known as water routing. That means he will study the route of the water where it gets distributed. So water source engineering deals with the physical control of water. So the responsibility is design, construct, maintain hydroelectric power facilities, dams, pipeline, pumping stations, etc. So an environment engineer is different in the sense environment engineer basically ensures the supply of potable water. That means a drinkable water to the community. So these are the things that we have studied in the last class. So I just gave another recap to the things that we have learned earlier. So hence we'll start with the next section in which we will decide the selection of site for a building. So in order to decide the site for a particular building, we need to consider a lot of things. So first thing is like if we are going to construct a building, let it be anything, let it be a industrial building, a commercial building, or a residential building, anything. So the following things should be ensured while we are selecting the site. That means the location of that building. First thing is the site should be fairly level with good quality of soil. The thing which a geotechnical engineer should ensure, the site should be fairly level with good quality of soil. So basically fairly level means we can't easily construct a building at a hillside. Especially we don't it's not at all recommended to construct a building where the slope goes beyond 45 degrees. It will be very difficult to construct a building over there. The stability of the soil will be very weak at that place. So the strength of the soil, the proper load distribution won't happen. So it is essential that we should select a fairly level area, even though it is it is not easy to find a level area. So what we can do is like we can use some techniques in which we can dump some soil or take away some soil, and we can make that level, that piece of land level. And the quality of soil should be good. Basically, it is highly recommended to construct a building where the soil is of rocky nature. That means it can properly take the load from the building. So we should ensure that the rock which lies under the building, the soil which lies under the building is of hard type. So hard type soil is best recommended, and you should understand that the best type of soil available in our region is actually the laterite soil, and in various parts of Kannur, this laterite soil is the most common type of soil found. So hence we can it is almost safe to construct a building where we can find laterite soil. So it is not at all recommended to construct a building where there is clay soil. For example, if we go to a lakeside or a riverside, we can find a lot of clay soil over there. Especially if we go to the Cochin region, the type of clay over there is very unstable. But it is in such a economic area where there it is essential to build various structures. We can't just say that we cannot construct a building over there because the soil is clay in nature. It won't be stable. The only thing we can do is we can stabilize the soil using various techniques. So all those things will come under the geotechnical engineering branch, where we will select a site, we will test the soil, we will ensure that soil is stable. And if the soil is not stable as our expectation, then we need to employ some techniques so that we can stabilize the soil. So there are several soil stabilization techniques a geotechnical engineer can employ. in order to make the soil stable. So all those things is if comes under the first point. The site should be fairly level with good quality of soil. Next is the location should be calm but reasonably developed. That's the main thing which we everyone nowadays recommend. It should be calm. It should not be on a busy side, whether it be any building, whether it be a commercial building or a residential building or a industrial building. The location should be calm, but it also should be reasonably developed. We cannot expect someone to build a huge building or a huge shopping complex near a forest area. The population in that particular area will be very low, so you cannot expect the income from such a building. So if we are going to construct a shopping complex, it is ideal to construct it near a recently developed area so that you can get enough customers. But if you are going to construct a residential building, it is not at all recommended to construct a residential building near a very busy street. So there will be a lot of pollution, whether it be air pollution or sound pollution that's happening in a very busy street. So you can't. It is not recommended to construct a residential building in a very busy street. Similarly, it applies to industrial building also. Industrial building will be located where we can get a sufficient amount of raw materials. Raw materials availability is very nearby, and it should be far away from residential buildings. It should have and also it should have a proper market to give out its products. So all those things we need to consider while we are selecting a site for a building. So next is like it should be well connected. So here we are talking about residential building mainly, and I'll explain how all these points will be different for residential, commercial, industrial buildings, and also institutional buildings also come into play. So the third point is it should be well connected by roads and other modes of transport. Is a very important thing which we should consider. We can't just consider to build to construct a building in a place where there are no modes of transportation available, or there are very less transportation facilities available. So it's always recommended to construct a building where there is ample amount of roads and other modes of transportation is available. So I hope you all understood that third point. Then the fourth point is like it should have good communication facilities. Good communication facilities in the sense it should have sufficient internet connectivity, sufficient postal services, sufficient banks. All those things will come under this communication facilities. So if you are going to construct a building, we should ensure that in our reachable distance, all these facilities should be available. Nowadays we can't skip basic thing, internet in our home. So we should ensure that there should be a mobile network in a place where we select the site for the building, and also it's necessary that we should ensure that internet connectivity is also available in that area. So this is the fourth point. It should have good communication facilities, and also the basic facilities, post office, networks, and also nowadays what happening is like in the case of an online shopping, the place should be available for delivery. So we can say that some places the online websites won't deliver our products. So that's a disadvantage basically, in nowadays where online shopping has been improved a lot. So we should this should also be taken into account when we consider the fourth point, that it should have good communication facilities. That means all these places should be available for delivery, whether it be from any online websites or even postal services, and all those things should be ensured. The fifth point, flood-prone areas, waterlogged areas, and reclaimed land should be avoided. Avoided in that sense. Flood-prone areas, waterlogged areas, and reclaimed land should be avoided. Flood-prone areas, we have understood what's the difficulty. For the past 2 years, we have been subjected to huge floods, waterlogging, and all those troubles. So we have understood what's the main difficulty if we choose a place where it is prone to floods and waterlogging. So during heavy rainy seasons, all these things can disturb our our regular lifestyle. So this should be taken into consideration. Now what happened is, like, after the two floods, people have started to think differently. Earlier, we always prefer to have our residential building or our home located to be located near a water source, maybe water like a river or a lake. But now people have started to understand that if something happens like a flood or a heavy rainfall, it will be too difficult for them. So people have started to think differently from earlier. So this is the thing. Sixth thing: flood-prone areas, waterlogged areas, and reclaimed land should be avoided. The next point is the site should have good natural ventilation lighting. That's also very important, because natural ventilation lighting is very important since it's directly related to the growth of several bacteria and other microorganisms. You will understand that wherever the sunlight is unable to reach, a lot of microorganisms will grow in that area, and that can harm our health. So we should ensure that our building should have a natural ventilation lighting. So in order to that, we should think not only in our land, in a particular purchased land, we should also see the surrounding. If any of the uh, surrounding buildings will block our light or our proper ventilation or wind flow, then we should avoid constructing that side, because it can harm our common health of the occupants. So this is the second last point. And the next point: the amenities like schools, recreation centers, shopping center, hospital should be near. So amenities like school, recreation centers, shopping centers should also be near to a building. So this is the last point which we should take care of. So what is the importance of having schools and shopping centers, hospitals, recreation centers nearer to our home? I need not explain. You might be knowing how important it will be for the general well-being and the progress of a particular person. So these are the things which we should take care. And then next is, like, sites should have quick drainage properties. The same thing what we have learned earlier. What is that? Regarding the flood control and flood prone areas or waterlogged areas, even though we need to understand that there are many cities in our state. In Trivandrum city, what happens is, like, whenever a rain happens, the city will get flooded like anything within hours, and also within next few hours, all those flooded water will be drained off. So the drainage facility should be planned accordingly, so that if by any chance the rainfall at that area is beyond our expectation or beyond our normal range, that should not cause flooding for several hours. It should it should drain quickly. So the next is, like, it may have regular shape with sufficient frontage. This is necessary since it is not at all recommended to construct or buy a property or a land which is of triangular shape or some irregular shapes. Always give preference to land which are of either square shaped or rectangular shaped. That's the best thing to do. So the regular shape should be maintained, and sufficient frontage should also be provided. So what happens is, like, basically in future, if a road expansion happens, if the authorities decide to increase the width of the roadway, so it should not harm our building. So we should give a sufficient frontage, so that even in future, if there is a possibility of road expansion, it should not harm our building. So the area must be sufficient for present and future development. The basic things we have discussed earlier. The places prone to air and water pollution should be avoided. the area which we are talking about here is some busy streets or industrial areas or such things. The proper ownership and other legal matters have to be checked before buying a site. This is also very important. That means we should not be uh, very quick in buying a property unless and until that we make sure that all these legal and other ownership documents are correct. The type of land use recommended at a proposed site should be complied as per the town planning or development schemes. So if you are planning a building, you should ensure that the type of land use recommended at that proposed site should be complied as per town planning or development schemes. So in every town there will be a town planning officer who will plan the town accordingly. So he will be dividing town into several areas like commercial area, industrial area, residential area. So if you are going to construct a industrial building in a residential area, it might be against the rule of that particular town. So we should take care that the the type of land use, whether it be industrial or commercial or residential, should be complied as per the rules established at that particular town. So these are the things which we should take care while we select a site for a building. So I hope everyone have understood all these things. Most of the things are self-explanatory. Still, I have explained some of the points in detail. Is Alan Joseph here? Alan Joseph.
Yes, sir.
So can you please explain all these points to your, in your own words, to your classmates?
Okay, sir.
Like explain any first three points. That will be better.
Okay.
Next.
So the good quality of soil.
Okay. How does that affect our selection of a site?
It should be a fair level with a good quality of soil.
And next, in your own words, just tell me how this is going to affect the selection.
Uh,
Would you prefer constructing a building on a hillside or on a plain surface?
on a paint surface.
Okay. Then would you prefer to construct a building at on a strength on a soil which is of poor strength or a good strength?
A good strength.
Okay. This is a basic thing which we the first point. The next point, please explain, Alden.
And it should be well transportation facilities.
The second point.
Um, it should be calm,
Mm.
but reasonably developed.
Okay. So where's your home located at?
Dolimanam.
Don't know exactly. Can you tell me a nearest town?
Irritating.
Okay. So how do you rate your place where your home is located as per the second point? Is it calm and is it reasonably developed?
Not much, but okay.
Means like, is it calm?
Yes.
Okay. Do you have all these basic amenities nearby?
Yeah.
Okay. So this is the second point basically. Even though uh, the place should be calm, should also be reasonably developed. That means we should have our basic amenities nearby. And the third point, Alan, can you please explain that?
The modes of transport.
Okay. Yeah, understood.
Connected.
Okay, Alan. So I think there's some problem with your network. Next, I'm shifting to Alina Gigi. Alina Gigi, can you hear me?
Yes. Yeah, yes, sir.
Alina, could you please explain me the last 4 points? which are Alan have.
Okay, sir. It should have good communication. That means good internet connection, and also uh, more facilities. Okay. Should have good communication facilities. And next one, should avoid flood areas and the lands which cause uh, many problems uh, like that. And next one is they should have good natural ventilation, like we need proper sunlight. It helps the organisms, and also it also need for our good health also. uh,
Okay.
the next one, okay, it should near to schools, hospitals, shopping centers, because it is also necessary to our life. uh, okay.
Yeah, that's enough. More than enough. So good, Alan and Alina. So the next slide. Could anyone voluntarily come and explain any of the points? Can anyone voluntarily come forward? Kiran Prasad?
Yes, sir.
Okay, please explain some points in the slide.
The site should have a quick drainage properties, which
So
means
what does that imply?
uh, there should be a good facilities for people to drainage properties.
Yeah, what does that mean? Drainage.
It means waste and all disposals
Drainage
of
is like not only waste, even though it is
yeah,
of
water.
rainfall.
Yeah,
Even though rainfall happens, the water should drain off
yeah.
easily. Okay. The next point.
It may have regular shape with sufficient frontage.
So, what's the shape of the land on which your house is constructed, Kiran?
Rectangular shape.
Okay. So, why did you choose? Why didn't you choose a triangle shape?
It's not possible like this.
Okay. So, like if you are going to choose a triangle shape, most of our building plans will be either rectangular or square. So, if you are going to choose a triangle shape for that property, you may not be able to provide sufficient distance between the boundary and a building, so that can harm what future expansion possibilities. That's the main thing, and there are some other things which are related to beliefs that triangular properties are not good for construction. And the third point, Kiran, could you please explain?
The area must be sufficient to present and future development.
Okay, so how do you rate your own area on the basis of third point?
It's,
Where are you from?
it's what's that?
Where are you from?
I'm from Pioneer.
Pioneer. Okay, so are you close to the municipality?
Yeah,
Okay, so how do you rate your area?
it's a good place. Town is near to our house.
Okay,
You all have the facilities here, transportation and all.
so as per your expectation, what type of development will is going to happen in your area? Will it become a residential area, or any other institutions will come into that place, or some factories will come to that place?
No,
What's your
it's a
expectation?
residential area.
So you expect that area to be developed as a residential area in future, right?
Yes.
Okay. And next 3 points I'll call. Thanks, Kiran. So next 3 points I'll just call. Shall I call? Can anyone voluntarily come forward? I'll call Irene Teresa CB.
Yes, sir.
Okay. Please explain the last 3 points for everyone.
Air pollution and the places where we select should be free from air pollution and water pollution. Then proper legal matters, ownership and legal matters should be checked before we buy a site, or else it will create some other problems in future.
Okay.
Type of land. The type of land which we choose must be based on our town planning and development schemes, because if it is in a very remote areas, it's really difficult for us.
Okay.
And
Yeah.
whereas if it's a developed place, most of the opportunities, and it's really good for us because everything becomes more easier compared to remote places.
Okay. Very good, Irene and Kiran. So hope everyone have understood their explanations. So next, we will move on to the next slide, where we will study about the components of a residential building. As you all know, a residential building can be anything where people resides as their home. So it might be a one-story building or it might be a 100-story building. Whatever, if it is categorized as a residential building, then basically all the systems and all other facilities will be designed accordingly. So what are the components of a residential building? First thing is the substructure. Substructure is a portion of the building below the ground level which transmit the load of the superstructure to the soil. That means if we call in മലയാളം എന്താ പറയാ, നമ്മളൊരു കെട്ടിടത്തിന്റെ തറ എന്ന് പറയില്ലേ, അതാണ് സബ്സ്ട്രക്ചർ എന്ന് പറയുന്നത്. So the basic objective of constructing a substructure is to transmit the load of the superstructure to the soil. What all loads can be can act on the superstructure? Basically, the dead weight of that superstructure. That means the weight of the bricks, cement, concrete walls, concrete beams, slabs, everything will act. And also the movement of people can also be a load. And also if some other furnitures are added to that building, so all these loads, and also the rain load, wind load, all these loads will act on a structure. So all these loads should be transmitted safely to the ground. So that's why we are constructing a substructure. Basically, the idea is to find a hard surface under the ground, so that we can place our building on that hard surface. That's why we are always making a trench to construct a substructure. So this is the basic objective of a substructure, where we can transmit the load safely. Minimum, whatever the building, the minimum depth of the substructure should be 0.5 meter as per our specifications. The specification means as per our building rules, the minimum depth should be 0.5 meter. That too for a very small building where there are not sufficient loads. Still, it should be 0.5 meter, because we can't rely on the soil which is very close to the surface, because that might not be as stable as we expect. So we'll be digging a trench to find a hard strata, so that we can place our building on that hard strata. So this is a basic objective of substructure. The next is the plinth or the basement. So part of the building above the ground level and up to the floor level immediately above the ground. So once we reach the ground level, the area which is above the ground level and which is just below the superstructure, that means which is below our walls and below above our ground level, that area is known as plinth or basement. So this is also constructed. It will be we can see visibly. It will be visible to us. It will be above the surface. So that part is known as the plinth or basement. അതായത് നിങ്ങളുടെ നമ്മുടെ ഫോർ എക്സാമ്പിൾ ഒരു വീടാണെങ്കിൽ വീടിന്റെ തറനിരപ്പിന് മുകളിൽ നമുക്ക് കാണാൻ കഴിയില്ലേ, അതായത് ഗ്രൗണ്ടിന് മുകളിലോട്ട് കാണുന്ന ബേസ്മെന്റ് അല്ലെങ്കിൽ സബ്സ്ട്രക്ചർ ആണ് പ്ലിന്ത് എന്ന് പറയുന്നത്. If it is below the ground level, it's known as substructure, and if it is above the ground level but not including the walls, it's known as plinth or basement. The next is superstructure. Superstructure is basically whatever things is above the plinth level, starting from our walls to going upwards, it's known as the superstructure. So all the superstructure load will transmit it to plinth, which will be above the ground level, and then the total load will be transmitted to the substructure which is below the ground level. So this is the component of a residential building: substructure, plinth, and superstructure. So just understand these terminologies. So you will we can see a figure in this here, which is a ground level. Our ground level is marked here. This is the ground level. So as per our the definition of our components, what is a substructure? A substructure is portion of the building below the ground level. So starting from foundation concrete to foundation until ground level is the substructure. Then above ground level but below the walls, it's known as the plinth or basement. So this will be above ground level but below our walls, that is plinth or basement. Then above plinth level going upwards, it's known as superstructure. So this is the typical section of a building. You might if you can look into this, you might understand it a bit. So this is a section which is cut apart, so that this is the basic thing which comes along with our drawing of a foundation, where how we should design a foundation and our basement, all those things will be mentioned here. So if we look into detail, we will understand that the bottom part is actually a foundation concrete. So this is done in order to improve the area. So you might have learned about force and pressure. Here we will call it as stress. You might have learned about it. It's similar to pressure, where the given force is distributed in a given area. This foundation concrete, what the function is like, if we provide a foundation concrete, then we can increase the area of transmission of load. That means our stress will be less, hence the soil will be able to take that particular stress or force. So our force will have a capacity. It's known as the bearing capacity. That means the force maximum might be 200 kPa for particular soil. Some other soil will be 100 kPa. For other type of soil might be 300 kPa. So depending upon the type of soil, each soil will have a different bearing capacity. kPa means Newton per meter square. So that soil will be able to bear that much pressure. So if we want to if we are going to increase the area, then the load coming from the building will be distributed in a larger area, hence the stress will be less, and it will come below the bearing capacity of the soil, hence it will be safer. That's the basic idea of providing a foundation concrete at the bottom. But this will not be a reinforced concrete. It will be just a plain cement concrete, where we won't provide any steel bars in it. It will be just a plain cement concreting, and above that we'll provide a foundation. So if we are going to construct a home or a house or a small residential building, we will use this random rubble. Random rubble means we'll use stone as our foundation material. But if you are going to construct a large house which is designed by an experienced engineer, we'll be providing a reinforced concrete. That means we'll provide concrete with rebars. That means with steel bars in the foundation. So here, as per our drawing, it might be a small residential building. That's why we are using this random rubble. So each material will have different different markings. Here you can see all these round rubbles or round stones. That implies that all this area is constructed using rubble masonry. And foundation, it will be marked differently, that means it is concrete. Concrete will be marked differently. Here, above plinth in the step, all these 45-degree lines, two lines separated at the equal spacing, implies that this is brick masonry. We are using bricks in that area. Here we are using stones, and at the bottom we are using concrete. So this is our basement or substructure. Then next will come to our plinth. Next will come to our superstructure. So once we finish with our foundation concrete, we'll go with the foundation. And then after foundation is the basement. And basement, in between another basement, what we do is basically we will fill with sand or soil. And above that, we'll give concrete floor. Then we'll provide floor finish. Floor finish means any of our flooring materials, like might be a ceramic tiles or just plain cement or marble flooring, anything which is known as floor finish. So below the floor finish, we'll provide a floor concrete. This will also be a non-reinforced concrete. That means just it will not contain steel bars in it. It will just contain plain concrete, and below that it will be filled with soil or sand. And we can see the figure of the step. As per our drawing, the step is also constructed using brick. That's why it is marked differently. And above that, it's a door. The door will be the drawing of the door will be of this type. It is the regular standard of drawing which we will follow throughout all the civil engineering projects. So this is the standard of all the things which we follow. Next is the lintel. Lintel is actually done in order to transmit the load above, brick masonry load above, safely to that substructure. For example, in some cases, we will only provide lintel above doors and window grills, so that our doors and window which will be mainly made of wood. So that wood may not be able to transmit the load above. So there we will provide a lintel, and that lintel will safely transmit the load to its either sides, side walls, and it will be again transmitted to the ground. And above lintel will provide brick masonry, then roof slab, and then again parapet. So this is the basic, the standard or a very typical cross section of a building wall. So where will we provide a foundation? Wherever there are walls, load bearing walls, we will provide foundation. And if our walls are not load bearing, what we'll provide? We'll provide foundation just below our columns. Columns means pillars. You might have noticed the difference in the technique used in construction. If you are going to construct a very small residential building like a home or a house, so what happens is, like, we will provide the foundation below the walls. So we'll be designing that walls as load bearing structures. That means the roof will be resting on that walls. The walls will take the load from the roof and it will transmit. In some cases, we'll provide pillars, concrete pillars, so that the roof will be resting on the concrete pillars and beams and concrete pillars, and the walls will not be load bearing. So in that case, it is not necessary to provide foundation below the walls. In that case, we will just provide the foundation below the pillars. So these are the different techniques in which we construct our buildings. So we will go into in detail what is meant by foundation and all of the stuff. So first thing, it distributes the total load coming on the structure over a large bearing area, so as to prevent it from any movement. The first function of foundation is to distribute the total load coming from the superstructure over a large bearing area. So that any movement means basically the movement happening in a building will be vertical. That means settlement can happen. You might have noticed that in some buildings there will be cracks happening on walls, very large gap. What happens is, like, if you notice the foundation, you'll understand that the foundation might have settled there. That settlement will cause a crack on the walls. So it is necessary to ensure that the foundation is capable of taking that load. So that's the first thing. It distributes the total load coming from the structure over a large bearing area so as to prevent it from any vertical movement. The movement which we expect is actually vertical. In some cases where there is a more seismic earthquake activity or wind activity, we can also expect a movement in horizontal direction. But since we are talking about a very small residential building here, the only movement which we can expect is actually vertical movement. It's a settlement. Settlement happens when the foundation is not properly designed to distribute the load safely to the ground. So this is the thing. The next function of foundation is it ensures the stability of the structure as a wall to prevent it from overturning or sliding against the distributed forces as wind, rain, and frost. This is the thing what I've talked about earlier. So the foundation is the thing which holds the building in its position against overturning or sliding. Overturning means the building will be overturned. You might have seen how a vehicle is overturned sideways. Similarly, if some force, a horizontal force acts on a building, there are chances that the building might overturn. So our foundation, what does it do? It will hold our building in its position. So against the forces like wind, rain, and frost. So this is the second function of a foundation to ensure the stability. The third function, it provides a level and firm surface for the construction of superstructure. So in order to construct a superstructure, we will be using several levels. That is known as like Dempsey level, so that you might have seen how our local masons use a particular level bob something which they use so as to construct the building, construct the walls in a straight line. There shouldn't be um, any variation in the line along which the walls are constructed. So they use these level bobs so that it isn't aligned in the straight line, both horizontally and vertically. Otherwise, the load won't be transmitted properly, and it might lead to the failure of the walls if it's a load-bearing wall. So why we need to provide a foundation is like it will give us a level and firm surface so that we can construct walls on it properly. So it prevents unequal or differential settlement of the structure. So unequal or differential settlement is something different from equal settlement. So equal settlement is like a total building will settle equally at all points. If we have four corners of a building, all the four corners will settle equally. Maybe it's like 10 mm or 20 mm. So in those cases, what happens is like it is not as dangerous as differential settlement. In differential settlement, what happens is like any of our all these four corners might settle at different levels. One corner might settle 2 millimeter, other corner might settle 12 millimeter. On the other hand, other corner will go up by 2 millimeter. That's known as a differential settlement. Differential settlement is more dangerous than equal settlement. Equal settlement is also dangerous, but in comparison, differential settlement is much danger. So unequal or differential settlement should be avoided. So we'll always give a provision for equal settlement, like our water supply lines or pipelines or electric supply lines. All these things will be designed so that it can accommodate small amount of settlement, equal settlement. But what if unequal settlement happens, that different areas of our building settles different manner, it might lead to the breakage of this water supply and power supply lines. So that should be ensured. The next point is to ensure the stability of the building against undermining due to floodwater or borrowing animals. So this is the another trouble which we will have to face. Undermining or due to floodwater. That was the main reason of settlement of collapsing of different buildings in the last 2 floods happened in our state. What happened was like water was flowing through the underground of a building, and we many didn't know that was happening, and it took away the soil from the underground of the building, and the building as a whole just collapsed down. So if we are providing us a stable foundation, that will prevent this free flow of water at the below of our building. So this can prevent the free flow of water, and hence undermining what happen. And next is like borrowing animals. So basically animals, what they will do is like they will keep on borrowing our uh, below our building, so that it can reach any of our storage space, so that it can have its food. So it's doing it because it want to survive. But what does it do to us? It's going to disturb the stability of our building. So this borrowing of animals is actually not permitted. So if we construct a foundation with of sufficient depth, the animals that borrow won't be able to borrow further. So it will help our buildings to stand longer. So this is the basic thing which a foundation does, the functions of a foundation. So I hope everyone have understood. If anyone has any doubt on the above set points, please do inform. Hope all these points are clear. This is actually the basic function of foundation, and next we will discuss about the basic function of a plinth. So the thickness of the plinth wall depends upon the weight of the superstructure and the width of the foundation concrete. So many of our plinth walls will be designed accordingly, depending upon the weight the weight that is acting on the plinth wall. So plinth wall, I hope you understood the point, the place what is meant by plinth. This is actually the plinth wall, above ground level, below our main walls. So the thickness, that means it will depend upon the weight of the superstructure and also the width of the concrete. The minimum height of the plinth is usually kept not less than 45 centimeters. So this is the minimum height of the plinth, but we should keep always, it's 45 centimeters. So plinth, another function of plinth is like why we are keeping a minimum distance of 45 centimeters is to, in case if flooding happens, the flood water may not easily enter our house if our plinth level is located sufficiently above the ground level. Suppose this is the ground level and flooding happens here, it might reach our steps, but it won't reach inside our house. That's why we are keeping our plinth level generally more than 45 centimeters. And thanks is like and also another thing is like it will it will prohibit the entering of animals like snakes or other reptiles. Snakes and other dangerous animals won't enter our house if we kept the plinth level higher. So the next point is to transmit the load of the superstructure to the foundation. That we know it's between the foundation and our superstructure, hence it will help to transfer the load to the foundation. It protect the building from dampness or moisture. Earlier I said if flooding happens, this will prevent the penetration of water into our walls. So basically most of our walls will be constructed with brick masonry, and if over dampness happens to that, the brick masonry might lose its strength and which will lead to the collapse of the building. So hence plinth walls will prevent dampness and moisture being penetrated to our building, to enhance the architectural appearance of the building. So basically you will know you might have seen those buildings where a plinth wall will be kept higher, will have it will be aesthetically more beautiful. So it's in the aesthetic point of view. And next is like a damp proof course. So you need to understand that a damp proof course is a layer of waterproof material provided on the top of the basement to prevent the damage on the wall. It's called dam-proof course. So main objective of dam-proof course. So you can see there's a small dam-proof course above the pin level, but below our walls, it will be like 2.5 centimeter thick, and it will be mixed with some our dam-proof materials like there will be some liquids. You might have heard about Dr. Fix-It or some other liquids which are damp-proof in nature. So it will prevent the absorption of moisture by the walls from the foundation. Well, most of the cases of foundation will be moisture in nature. It will absorb moisture from the surrounding soil, but that moisture won't reach our walls. That's why we are using this damp-proof course. So that's actually 2.5. Commonly, we will provide 2.5 centimeter thick damp-proof course just below our walls. So this is the main thing, and it is known as DPC. It's officially technically known as DPC, damp-proof course. And next, the main function of floor is to provide support for occupants, furniture, and equipment. Divide the building into different levels for creating more accommodation within the limited space. All the floors, whether basement, ground, or upper, should be strong enough to support the floor covering and other superimposed loads. The floors provide clean, smooth, impervious, durable, wear-resisting surface with adequate fire resistance, sufficient heat, and sound insulation. So going forward, because I'm going quite fastly because you know what's the function of a floor. It is to accommodate the occupants to provide a safe living environment. That means if a floor is dirty, if we are not giving a floor, what is below that? It's just soil, and it won't be. It will be dirty most of the time. So if we provide a proper floor, it will enhance our livability in that place. Next is walls. The main function of the walls is to divide the space into different rooms. Walls support the load from the roof, upper roofs, the foundation. If it's a load-bearing walls, if it's not a load-bearing walls, then it's just used to divide the rooms. So piers or pillars are thickened sections of the walls placed in intervals to carry the concentrated loads. So this is the case. The third point is the case when we are using non-load bearing walls. That means the loads will be transferred to piers or pillars kept, and we'll just provide walls which won't take any loads, but just to divide our rooms. So it should be stable against overturning by lateral forces. That means it should be stable, means any lateral force, any horizontal force is acting on that. If suppose if a few of our the occupants are leaning towards the wall, it should not fall down. So that should be. It's not necessary that always of wall should be constructed using brick. Nowadays, we are separating our walls with cardboards. What happened is like all the buildings nowadays are being constructed such that we are using non-load bearing walls. That means we need not provide brick walls, so that there is no use to already the load is being properly distributed using pillars. There is no need to provide load bearing walls. These are the things. The external wall should provide sufficient resistance against weather agencies like sun, wind, and snow. Wall should have sufficient heat and sound insulation. You know the reason. Privacy and security against burglary. Then it's against this. And next is doors and windows. So that we'll discuss in the next class. I hope it's time to conclude. But you need to understand, if you look at the figure, you will understand that as we move from top to bottom, the load will cumulatively increase. That means at the roof slab, the load above roof slab will be the load from the parapet. But when we reach lintel, all the loads above lintel will come into play. Similarly, if we reach a plinth, all the loads above will come into play. So it's all cumulative. It will keep on adding as we move from top to bottom. Similarly, you need to understand that once we reach ground level, it will contain the load from the plinth, the walls, the brick masonry, roof slab, lintel, everything. As we go bottom, the load will always keep on increasing. So since our load is increasing, we are increasing the width of the supporting structure. This is the basic idea. As the load increases, we should increase the width of the structure. So as a structural engineer, what someone is expected to do is like, we will analyze what loads are acting, and we will decide what should be the size of each of these components. This is the thing with what a structural engineer does. And once it reaches the foundation, this is the role of geotechnical engineer to ensure the safety of the soil. So this is the basic thing which we have discussed about foundation, plinth, and floor, walls. Next we'll discuss about doors and windows in the next class. So I hope everyone have understood and have found this class interesting. If you have any suggestions, please do mail me, and you might know my mail ID. It's peterjob@vjec.ac.in. So you can mail me, and if you have any suggestions or if you expect any improvements from my side, you can always contact me and inform the same. So once again, I thank everyone for being present in this class. So thank you all.
Thank you, sir.
Record.
Thank you, sir.